Welcome to Ixia product demonstration.
In this session, it will be demonstrated how Ixia PCC solution can be used to test functionality and scalability of a PCE responding to path computation request messages coming from PCC. The topology consists of two Ixia ports connected back to back. On one port, there is an emulated ISIS SR node behind which there is a network of simulated ISIS SR routers. Two such nodes are configured as PCCs. The PCC loopback address will be advertised by the ISIS SR as node SID. On the other port, there is an emulated ISIS SR node behind which there is another network of simulated ISIS SR nodes. For demo purpose, the PCE, which is the device under test, is also emulated on the right-hand side port. While testing with real device under test, this PCE will be connected to the Ixia ports via one or multiple ISIS SR routers. The PCE will build up its traffic engineering database using information learned from ISIS SR. Now let us see how the PCE's capability of path computation can be validated when PCC sends PC request message to reach certain destination. To do this, in the PCC, one has to configure number of PC request messages to be sent out as shown here. This can be scaled as required. One can configure the source and destination IP address along with the PLSP ID, bandwidth, metric or IROs to be sent in the PC request message. The destination addresses used are there in the network cloud named Simulated SR Nodes 2, which the PCE has learned through ISIS SR and will use that information to compute LSPs accordingly and send it in PC reply message. Ixia PCC also supports sending multiple LSPs bundled together within a single PC report message, which helps validate PCE's capability of handling bundled messages. Also, the number of PC request messages sent within a defined time duration can be configurable, thereby putting a rate control on the PC request message transmission. Configuring different rate, user can test PCE's efficiency of processing frequent PC request messages. Last but not the least, Ixia PCC supports MD5 authentication as well. Authentication can be kept null or MD5 on a per PCC basis with different MD5 key. While authentication is configured MD5, all PCEP message exchange will happen with MD5 encryption. Let's now start the protocols. Once the PCEP session is up, PCC sends all the PC request messages and PCE replies back with PC reply messages. These reply messages can be validated by checking the learned info at PCC. This is how the PCC learned info can be retrieved. It can be seen that PCC has learned the LSPs that PCE has computed and sent as PC reply message. The highlighted portion shows information learned for a single LSP. User can see the PLSP ID, symbolic path name, and MPLS labels associated with the LSP. The same can be validated by looking at a very rich set of PCC statistics, which shows session status related statistics and transmit receive statistics for different types of PCEP messages. Here it can be seen that PC request message transmit, PC reply message received have been updated as per the number of messages exchanged. Analyzer support is also there to see messages exchanged between PCC and PCE. This helps in troubleshooting scenarios by analyzing what's happening actually on the wire. We can filter out certain type of messages, for example PC request messages sent out by PCC as shown here. Finally, one can also send traffic over the learned LSPs to validate whether the end-to-end path computation was rightly done by PCE. If the traffic created with label stack as learned from PCE is properly forwarded and received at the destination, then it is proved that the path computation by PCE is correctly done. If the traffic fails to reach destination, then the path computation done by PCE is improper, in which case traffic flow statistics will show packet loss. First of all, the endpoints need to be selected properly. There is an option to filter out PCEP endpoints as shown here. The requested LSPs are selected at the ingress PCC and destination is selected as the SR nodes. The traffic can be tracked per LSP. Track by flow descriptor will result into per LSP flow statistics and will show the symbolic path name of the LSPs. Flow statistics shows transmit-receive statistics for each LSP as shown. The LSPs can be identified by the symbolic path name shown under the MPLS flow descriptor column. Once the traffic is started, one can see the flow statistics per LSP and validate whether end-to-end traffic is flowing properly over the LSPs computed by the PCE. This is how Ixia PCC solution can be used to test PCE's capability of path computation and respond to PC request messages. Ixia PCC solution can also be used to test PCE capability to process and build its LSP database from sync LSPs sent out by PCC as part of initial state synchronization mechanism. In this scenario, PCC should have some pre-established LSPs of type SR for which it will do initial state synchronization with the PCE by sending PC report message with sync bit on. One needs to configure the pre-established LSPs as shown next. Configure the number of pre-established LSPs for which initial state synchronization will be done by the PCC. User can configure different sync LSP parameters like ERO, LSP, bandwidth, etc. and use PCC statistics and packet capture to validate message exchange between PCC and PCE. Last but not the least, Ixia PCC solution can be used for testing PCE's capability of instantiating PC-initiated LSPs and sending PC update messages if some change is detected in the underlying ISIS SR topology. Let's see how to configure PCC for this purpose. Ixia PCC needs to know how many PC-initiated LSPs the PCE is going to send a priori. This is needed so that later data traffic can be sent over these LSPs. So, one needs to configure this list of LSPs along with the expected symbolic path name and source of the traffic. The symbolic path name configured here has to be same as carried in the PC initiated message sent by the PCE. Once PCEP session is established, PCE will send PC initiate message and a later point of time it may send PC update message. User can verify PCE's behavior by the rich set of PCC statistics and the PCC learned LSP information along with packet capture. This was all about the Ixia PCC solution, which can be used to test a PCE for all types of SR LSPs as discussed in this session.
Thank you for your time. Please watch our other product videos for more information.